All right, today we're going to look at lesson 5.1, which is solving systems of linear equations by graphing. So the first half of chapter 5 is going to be all about solving systems of linear equations. Now, hopefully, when you see the word linear equations, you know what types of graphs we're talking about. Can anybody raise your hand and tell me linear equations have what kind of graphs? Daniel.
A line.
Very good. A line. Linear, L-I-N-E, line. All right. We've done 3 types of forms of a line. Does anybody remember the 3 different types? If you can at least remember one, raise your hand and give me at least one type of line. LJ? No, not exactly. The form of the lines is what I'm asking.
Vertical. Wait, is that what you're talking about?
I'm talking about the different forms. But yes, a vertical line is considered a linear equation. So that's not completely wrong. But we've learned 3 different forms of a line that we can write and we can graph. No. Slope-intercept form. Very good. What is the slope-intercept form of a line? Y equals mx plus b. What's another form of a line that we've learned? Point slope. All right. What's the point slope form? Y minus y sub 1 equals m times x minus x sub 1. And what is the third form? No. Slope is slope-intercept. We've got point slope, slope-intercept. Nope. It does start with an S, okay? But it's not slope. We already got point slope and slope-intercept. AX plus BY equals C. What form is that? Standard. Very good. There it is. Okay. So we've learned 3 different forms of lines. They all essentially on a graph are going to be straight lines. Okay. So that's just a little review for you. Now, the 2 equations or the 2 definitions I did not have you write down. Just a quick review. Linear equations. An equation with an X. Notice I said and or a Y. Okay, this is important. And you guys were already kind of talking about this a second ago. I want you to understand that a linear equation could be x equals 5. It doesn't have to have a y in it. If I have the equation x equals 5, what kind of line am I graphing? A vertical line. Very good. If my equation is y equals -2, what kind of line am I graphing? Horizontal. Okay, and then of course if the equation has both an x and a y, I'm graphing some sort of slanted line, okay? But an equation with either an x and or a y whose graph is a line, and we've already talked about that, okay? Remember back a few chapters when we talked about the solution of an equation. What made an ordered pair a solution to an equation? Well, it was a point that when we plugged it into the problem made a true statement, okay? That base right there is going to help you with what we're learning today. So a system of equations, 2 equations that relate to one another. So a system of equations is 2 equations. Now, eventually, you may see 3 equations, okay? But for right now, basic, 2 equations. A system of equations is 2 equations that relate to each other. Now, a solution of a system. Pay very close attention. Make sure you wrote this down. It's one point that when plugged in makes both statements true. All right, let's say that again. It's a point that when we plug it into both statements, it's very important. If the point does not work in both statements, it's not a solution. It essentially is the point of intersection. When I graph those 2 lines on the same graph paper, the point where they intersect is called the solution of the system. All right? So, with all of that being said, let's look at example 1. Now, very simply, it says tell whether the ordered pair is a solution of the system of linear equations. So we're going to plug the point that they've given us into both of our equations. Jenna, what's the point that they've given us to try? Good. And for those of you who might still struggle, remember the first coordinate is my x and the second coordinate is my y. Now, my first equation is 2x plus y equals 0. All right, and I'm going to plug in my values. So 2 times, Jenna, what's my x value? plus, what's my y value? And it's supposed to equal 0. Now again, you've noticed this from day one. I plug things in parentheses. That way I don't forget to multiply. All right? 2 times 1 is?
2.
2 plus negative 2?
0.
So 2 plus negative 2 is 0. So, does that make a true statement?
Yes.
Awesome. So if it works in the first equation, I got to keep going. I can't automatically assume, oh yeah, it works, it's a solution, because it has to work in both equations. So the second equation we're working with is negative x plus 2y equals 5. So again, be careful because the negative is in the equation already. What am I putting in place of x?
1.
1 plus 2 times what's going in place of y?
Negative 2.
And it's supposed to equal 5. So negative 1. What is 2 times negative 2?
Negative 4.
Negative 4. And it's supposed to equal 5. What is negative 1 minus 4?
Negative 5.
Negative 5. Now, does negative 5 equal 5? So that is not a true statement. So is this ordered pair a solution to our system?
No.
So not a solution is your final answer. Now, is all that work necessary? Yes, because I'm not going to give you credit if all you write is not a solution. I need you to prove it. All right, when we plugged it into the first equation, it worked, but when you plugged it into the second one, it did not. All right, any questions? All right, work with your table on letter B. All right, let's see how it went. Blake, in the first equation, y equals 3x plus 1, what did you plug in place of y? 4 equals 3 times, what did you plug in place of x?
1.
Plus 1. So 4 equals, what is 3 times 1? And what is 3 plus 1? 4. So, is that a true statement? Does 4 equal 4? Yes. All right, so we're going to keep going. Okay, other Blake. The second equation we have is y equals negative x plus 5. So again, what's going in place of y? 4. And it equals negative, what do we put in place of x? 1 plus 5. So 4 equals, what is negative 1 plus 5? Is that a true statement? So since it makes both statements true, it is a solution. And that's what we're going to box in, solution. How many of you got the right answer? Awesome. Any questions? All right. Now, I gave you these steps because while we are going to use Desmos here in a second, what happens if you don't have a cell phone on the day of a quiz or a test? Or what happens if your cell phone dies on the day of a quiz or a test? Or what happens if your phone has no more memory and you can't put Desmos on to your phone? Okay? How are you going to graph and solve the system with graphing if you don't have Desmos? All right? Here it is. You're going to put the equations in slope-intercept form. As a review, what is slope-intercept form?
Y equals mx.
Awesome. Y equals mx plus b. If you know nothing else leaving algebra, you're going to know that. Okay, y equals mx plus b. Graph both equations on the same graph. If I'm looking for the point of intersection, it makes no sense to graph them on separate graphs, right? I'm graphing them on the same coordinate plane. I'm then going to find the point of intersection, and I'm then going to plug the point into both equations to see if it's a solution. You say, why do I have to do that? Well, when we as humans are drawing our own graphs, sometimes we don't use a straight edge, or sometimes we don't use a piece of graph paper. And if our line is even slightly off, our point of intersection might be off. So what's the quickest way to make sure we have the right answer? Plug it in and make sure it works in both equations, all right? So that step 4 is also if the instruction said solve graphically and check algebraically, that would be what you do. You take your point of intersection, you plug it back in, okay? But for example number 2, we are going to use Desmos. So go ahead and get your phones out, lay them flat on your desk, and open up Desmos. All right, now you guys have the equations in front of you, so I'm going to call on some of you to help me. But we are going to type the equations exactly as we see them. Okay, that's the beauty of Desmos. I don't have to have it in slope-intercept form. I can put it in standard form. I can put it in point slope form, which won't normally happen, but I can put it in slope-intercept form. But if you're looking at example 2, letter A, what is, Jenna, the first equation that we need to put in?
Y equals x minus 2.
All right, so y equals, you said x minus 2?
Yes.
All right, and there's our first line. Now, there's no boundaries this time, no piecewise functions, just a good old-fashioned equation. All right, Joseph, what's the next one we need to put in?
I don't know. I didn't get that one.
All right, Sarah?
Oh,
The second equation. We're on letter A. Example 2, letter A. What's the second equation?
y equals negative x minus 2.
All right, y equals negative x. What was it?
Minus 4.
Minus 4. Awesome. So, there is my second line. Now, if you need to move it around a little bit, if you need to zoom in or zoom out. Yes, Vonasia. Yours says plus 4. Did anybody else say plus 4? Okay. So we need to get that fixed. It is plus 4. There we go. All right. Now, Desmos has done the work. We now just have to transfer it onto our paper. So let's talk about how we're going to do that. First thing I want you to find is the y-intercept. Okay, we already know if we're graphing a line by hand in slope-intercept form, we always graph our y-intercept first anyways. So let's find it. All right, Cam, on the blue line, now my line is blue, what is the y-intercept? What are the coordinates of the y-intercept? So the y-intercept is at 0, 4. So that would be the first line that you put on your graph paper. All right, you would plot 0, 4. Now, I would ask you to find one more line. Okay, what's one more line? And you can really follow the slope here. The slope of this first equation, or this blue line is this equation. The slope is a negative 1. So you can go down 1 and right 1. But what is another point on the blue line? Give me the coordinates.
4, 0.
Okay. 4, 0 down here?
Yes,
All right, that'll work. Can do 4, 0. All right, awesome. Now let's do the red line. All right, Andrew, what is the y-intercept of the red line?
Negative 2.
Give me the coordinates.
0, negative 2.
Right here, 0, negative 2. Awesome. Give me one more point, Bryce, on that line. Okay, 2, 0. Right here, that's another point you can draw on your line. Now, how many points do I love on a line?
3.
3. But right now I only had you put 2 down because where is the point of intersection?
Is this 8?
What are the coordinates of the point of the intersection?
4, 1.
3, 1? I heard 3, 1. Right 3, up 1, and that is your point of intersection. So your third point that you're going to plot on your graph is that point of intersection. Now, what is the answer to the problem? Because what did the instructions ask you to do on example 2? Vonasia, read me the instructions for example 2. All right, so we're back at question A. It says, example 2, solve the system of linear equations by graphing. So we've graphed it on Desmos. It's on our graph paper. So what is the solution? Vonasia? If you need to go back and look at the definition of the solution, go back and look. But what are we looking for? What is the solution to a system of equations? If you did not add the point of intersection to the definition, you need to add the point of intersection. If you go back to that very first screen, the solution of a system, point of intersection. So looking at the graph you just put on your graph paper from Desmos, what is the solution to letter A? What is it?
3.1.
3.1, no, I need an ordered pair. 3, 1. Is that not the point where the two lines intersected? Guys, this is so simple. So let it be simple. Desmos did all the work. You transferred it onto your graph paper. Where is the point of intersection?
3, 1.
Then the answer to this question is 3, 1. Awesome. Now, work with Desmos, work with your table partners, and do letter B. All right, let's see what you guys came up with. If you're still working, that's fine. Work, but I'm going to start putting it on the screen. All right, Haley, what was the first equation that you guys plugged in? 2x plus y equals what?
5.
Now, this problem is in what form? 2x plus y equals 5. Remember the three forms we talked about at the beginning? Point slope, slope-intercept, standard. Which one is this? Standard. Was it necessary for us to change it to slope-intercept before we plugged it in? No. That's the beauty of Desmos. So, in standard form, we have a line. All right? Anthony, what was the second equation that you guys plugged in for this one?
3x minus 2y equals 4.
3x minus 2y equals 4. So once again, we have a beautiful set of lines that intersect. So we're transferring this onto our graph paper. What is the y-intercept of the green line, LJ?
Y-intercept of the green line would be 5. 0, 5.
0, 5. So we're going to plot that point first on our graph paper. What is one other point on the green line, LJ?
That would be
LJ, you see 4, negative 1?
Ismael.
So 1, 2, 3, 4, negative 1 is right here.
Oh, I meant 3, negative 1. Sorry.
Okay, 1, 2, 3, negative 1. That works. All right. You also had 1, 3 right here. You could have used as well. All right. As long as we have one other point, we're good. Now, the purple line. Blake, what is the y-intercept of the purple line?
Negative 2.
Give me the coordinates.
0, negative
So from the center down. Perfect. What's another point, Blake, on the purple line?
2, 1.
Okay, but that's the point of intersection. Remember, that's going to be my third point. All right, 4, 4. We go right 4 and we go up 4. Right there's a point. Awesome. Now, for our third point, we're going to choose the point of intersection. So you've got your two lines drawn by this point. Haley, what is the point of intersection of these two lines? All right, 2, 1. We go right 2, we go up 1. There is our point of intersection. So we plotted on our graph paper. So now both lines have 3 points. And what is the answer to our problem?
2, 1.
The point of intersection, which is 2, 1. So that is the answer to letter B. Because the solution of a system of equations is the point of intersection. It's an ordered pair every single time. All right, example number 3 says, write a system of linear equations solved by graphing. Now, we've got to get way better at reading word problems and being able to dissect them and figure out how to write them. So let's read this and let's take it apart. You have a total of 18 math and science exercises for homework. Now, our first thing that we notice is total of. What operation are we talking about if we say the total of?
Addition.
Addition. So, what are we adding together? What two things are we adding together to get a total of 18?
18 is science.
Math questions and science questions. So, for right now, let's use an M and an S. So, our math questions plus our science questions is going to equal how many total questions? 18. And look at that. There's our first equation. Now, that's how simple usually our first equation is when we're trying to write a system from a word problem. Now, let's keep reading. You have 6 more math exercises than science exercises. So, are they telling me what M equals, or are they telling me what S equals? If I have 6 more math exercises than science exercises, do I know what M equals, or do I know what S equals? But I have 6 more math than science. So they're giving me S, right? Isn't there information about the science questions? Because I have 6 more math questions than I do science questions. So I'm going to use, instead of M equals, I'm going to use S equals. Now, 6 more than. Is that adding 6 to the math questions, or is that subtracting 6?
Adding.
That's adding 6. So m plus 6. Now, what do I have? I have a system of equations, right? I've got two equations. Now, here's the only thing. I'm not going to plug an m and an s into Desmos. So, I've got to decide what I want to be. Let's make our m our x, and let's make our s our y. So, plug the two functions into Desmos, and let's see what the solution, how many of each type of question do we have? All right, let's plug those equations in. So it was x plus y equaled how many? 18. And then for our second equation, we had the math questions. Or did we have the science questions equaling? So was that our x or is that our y? That's our y. Okay, we said our science questions was our y. So y equals x plus 6. Now we're going to have to zoom out a little bit. And there's our point of intersection. Now, again, I'm going to find my y-intercept, which is right here at 6, 0 for my red line. If I find one more point, I have one at 1, 7. And then my black line is a little bit higher. It's at way up here at 18. And I've got a point at 1, 17. But what is my point of intersection? Where's the point where these two lines intersect? Can anybody tell me the coordinates of that one?
That will be 6,
Okay?
12.
6, 12. So if we write that down as an ordered pair, we have to dissect it. We said 6 is our x, right? We said 12 is our y. But our x values represented math or science? Math, and our y represented science. So, how many math exercises are in our homework? 6 math exercises. Because remember, this is a word problem, and we always label. And how many science exercises? 12 science exercises would be our final answer. But do you see how we still find that point of intersection to help us find how many math exercises and how many science exercises? And that is lesson 5.1.